Recall that any expression that is divided or multiplied by 1 is unchanged. This, together with the fact that any non-zero number divided by itself is 1, leads to a rule for division. In this first example, if we take this exponential notation and express it in factored form, in the numerator, we have the base of x times itself 3 times, as indicated by the exponent. Likewise, in the base or denominator, we have a base of x to the second power, so x times x. And since we have common factors over one another, we can simplify since x over x is equivalent to 1, x over x here is equivalent to 1, leaving us with a value of 1x, x to the first power. In this example here, writing it in factored notation, we have the common base of a multiplied by itself 5 times, as indicated by the exponent. Denominator, common base of a multiplied by itself 3 times. Since these are multiplied together, a over a cancels out and is equivalent to a 1. A over a, since it's a factor, also cancels out to equal 1. Likewise here, leaving an a times a or an a to the second power. If you note our result from what we had, subtracting the exponents, 3 minus 2 leaves us with x to the implied first exponent. 5 minus 3 in this second example results in a2, which leads us to the quotient rule. For any non-zero number a and any positive integers m and n for which m is greater than n, we have the following rule. A to the m divided by a to the n can be simplified by taking the difference of the numerator exponent and the denominator exponent. Putting that rule into use on this example here, we have common bases. Our numerator is greater than our denominator exponential power, so the solution will be the difference of those powers, and we end up with an equivalent n to the third power. In this next example, regardless of whether the base is a number or in this case an integer versus the variables that we've been looking at, same quotient rule can be used since we have a common base. The power is greater in the numerator than the denominator, so simplifying, we're going to take and subtract the exponential powers and have a simplified equivalent value of 5 to the 9th power. Although it looks complicated, rather than just a single variable, we have the same base to a power divided by the same base to a different power, which means we can take that common base, and because it's dividing common bases, we can use the quotient rule and subtract the exponents, 5 minus 3, to give us a simplified common base 2xy to the 5 minus 3 or second power. In this last example, we can break this fraction up into its parts, and by that I mean similar terms in those fractions so that we have common bases in the numerator and the denominator. If we multiply these fractions together, we do get the numerator. If we multiply the factors in the denominator, we get our original denominator. Then simplifying each one of those fractions, we can reduce the 7/14, since 7 divided by 7 is 1, 14 divided by 7 is 2. We have our common basis where we can subtract our exponents, which, if it helps, we can put the implied exponential power on y, which is y to the first power, which leaves us with 1/2 x to the difference of those exponents, since it is in a division problem, times y to the numerator exponent minus the denominator exponent. And simplifying, then we have 1/2 x to the 4 minus 3 first power, which I'm going to leave. It's an implied first power, times y to the 3 minus 1, or exponent of 2.